I'm going to show you a couple more examples of trig equations, but this time they're going to have quadratic expressions in, with squares in. And I'm going to show you what to do in that case as well. So for the first one, you've got tan squared equals 4 in the interval of 0 to 360 for theta. It looks as if I can take square roots right away, so I'm going to do that first of all. Square root both sides. Tan theta is plus or minus 2. It's important that you remember the plus and minus version. If you take these cases separately, you can then figure out separate sets of values for each case. So on this side, if I do tan theta equals 2, I can use my calculator to get a value for theta, and the principal value is 63.4 degrees. It's using the inverse tan function. But then, because of my wide range of values for theta, I can add 180 to that and get a second value. And the second of which is 243.4. Okay, then if I add 180 to this one, I'm going to go past my value of 360, so I know I've got enough that side. And if I subtract 180, that will make me negative, which I can't have either. So these are my two possibilities for tan theta being equal to 2. Separately, if I do tan theta equals minus 2, I can do a similar sort of thing. I can use my calculator to get the first value, and the calculator tells me minus 63.4 this time. But that's not in my valid ranges of theta. So if I add 180, I can get into this portion of the graph. And the second value I can get is 116.6, which is in the right range. If I add 180 to that, I can get a second value, which is 296.6. And then if I exclude this value that doesn't count, in total I've now got 4 values of theta, which I put as my answer. Okay, so this time I didn't draw the graph, but all I'd used was the fact that tan theta has a period of 180 degrees. For this second example, what you've got here is you've got a mixture of coses and sines, some of which are squared. So ideally what we want to do is to get to a situation where we've only got one trig function going on. And what I can do to do that is I can use an identity. You're already thinking of it, hopefully. It's this one. Sine squared x plus cos squared x equals 1. Now, looking at what we've got a cos squared here, and then everything else appears to be a sine x. If I want to eliminate one of these trig functions, I think it would be best to eliminate the cos squared, so you're left with sines everywhere. If I were to eliminate the sines, it would be difficult to eliminate this one because it hasn't been squared. So what I'm going to do, I'm going to rearrange this over here, so 1 minus sine squared is the same as cos squared, and then I can do a substitution. So this is what my equation becomes. It's 2 lots of cos squared is 1 minus sine squared plus 9 lots of sine x equals 3 sine squared. Okay, this looks a lot better because now I've got only one trig function, which is sine of x. I want to get to a situation where I've got a quadratic equation, so I'm going to expand everything out. 2 times 1 is 2. 2 times minus sine squared is minus 2 sine squared. Plus 9 sine x equals 3 sine squared x. Okay. Now I can think of these terms as being the terms of a quadratic equation. If I collect everything together onto one side, I'm going to put it on the right-hand side. You're going to get 0 on the left, and that's going to equal 5 lots of sine squared x. I'm going to be subtracting 9 sine x, and I'm also going to be minusing this 2. Okay, now my algebra is all in a quadratic shape. I can treat it like a quadratic equation, and I can then solve for sine x. So what I'm going to do, I'm going to try and hopefully factorise this expression, but we're going to be thinking of this sine x term and this sine squared x term as just a single variable like you would normally if you were factorising it with x's and x squareds. So I'm going to draw some brackets in. That's not an amazing bracket, but you know, whatever. I want to have brackets that multiply out to make these three terms, so I think you're going to have 5 lots of a sine x and a single sine x. That's going to make the first term. And then to make these other terms, with a bit of trial and error, you can figure out what the rest of the brackets are going to be. I think it's going to be minus 2 over here. That's going to make my minus 10 sine x. And then I'm going to add back a single sine x term in the middle here. And that's going to make it work. And then to check, you can expand it out, and it makes these 3 terms here. Okay, so I've factored my expression. I can then try and get its values of sine x for each bracket. So for the first bracket, it looks like sine x equals minus a fifth. And for the second bracket, it looks as if I can get sine x equals 2. Now, for this second possibility, we'll notice that this doesn't actually happen, and there is no value of x for which sine x equals 2, because looking at the graph that we've got over here, sine x doesn't ever go higher than 1, and it never goes below minus 1. So these values can be discounted because there's no such x. For the first possibility, though, I can get values of x for this. This is in the right range of values for sine x. So I'm going to inverse sine on my calculator. Just going to do that. The first value of x I get is minus 11.5 degrees. That's from my calculator. I'm now going to look over here at what range of values of x I'm allowed to have, and it looks as if I can have between minus 180 and 180. So this is a valid solution. This is in that range. I'm going to put it on the picture. And based on what I've got in my picture, if this is my first solution, it looks as if I've only got one more solution over on this side over here. So what I'm going to do, I'm going to work out what happens if I reflect over here. And it looks like that's minus 168.5. So I added 11.5 degrees to minus 180 degrees, and that's what I got over there. And that's my second solution. Okay, and based on what I've got over here, this is my range of values, those are the only solutions. So I'm going to add that across over there. Okay, so that's how you solve a quadratic trigonometric equation.